Okay. Well, there is no particular reading for today because I thought it was time to pull things together and supply some of the context that I advertised in the title of the course, Frege, in context. And so part of that was to be the discussion of Bolzano that I hope you found an enlightening bit of context. And I want to start off just with mentioning two things that I didn't get around to saying last time about Bolzano before I go on to talk about the context on the one hand in Kant, and then looking a bit ahead, and then looking all the way back at how Euclid was important to Kant and setting up the issues that Frege is going to talk about. So what I did emphasize last time about Bolzano is he has an ontology of worldly propositions, Sätze, that have parts, the Vorstellungen, the representations that are parts of them. He says it's the parts plus a mode of combination of them. And he's most interested in understanding the mode of combination, which he says you can only understand in terms of the relations that a Satz stands in to other Sätze. Those worldly propositions come, according to him, with truth values that are unchangeable. If you think that some sentence expresses a changeable proposition, that's because it really expresses a whole set of them. You haven't settled one of the parameters of it. But if you do, if you get one of these Quinean eternal sentences, then it's simply true or false. So there's no notion, and really no room for a notion for him, of truth conditions as something beyond the extensional on-off for each of these propositions. But if we ask, well, what is it to grasp a proposition? What do you have to be able to do in order to understand one of these things as what's expressed by an appropriately perspicuous sentence? And the answer is, well, you need to know what follows from it, what it follows from, what it's incompatible with, the relations of consequence and incompatibility that it stands in. And to understand those, you have to understand the relations between that Satz and the other ones, which are substitutional variants of it. The tradition is very impressed with this thought as an anticipation of Tarskian model theoretic notions of consequence, but I argue that they underestimate the significance of the fact that he thinks of the relation between premises and conclusions in a generalized consequence relation as triadic. It's a relation between the premises, the conclusion, and some analysis of the premises and the conclusions. And the analysis takes the form of a partition of the vocabulary into vocabulary to be held fixed and vocabulary to be varied. And then the notion of consequence is that a consequence holds relative to an analysis if every variant of the variable vocabulary that makes the premises true also makes the conclusion true, or in the case of incompatibility, makes the conclusion false. So grasping the content of one of these Sätze is placing it in the space of all these relations. You have to know how to tell, in effect, if we changed these parts of the premises, and changed correspondingly those parts of the conclusion, which of the implications would still hold? If these were true, would this be true? And we need to be able to do that for all of the different substitutions. In effect, this is a modal notion. He's quantifying over the variants and looking at the distributions of truth values with respect to them. So it's the ranges of subjunctive robustness, or something like that, of the truth values of the premises and the conclusions that you have to get practical mastery of in order to count as understanding the proposition. And I argued the fact that Tarski only considers one way of dividing the vocabulary into fixed and variable, namely where the fixed vocabulary is purely logical vocabulary and the other is not. That's a huge constraint on the Tarskian picture relative to the expressive power of the Boltzannian picture, which precisely lets us think about consequences that hold in virtue of the theological form, the geological form, the culinary form of the proposition, depending on which vocabulary, non-logical material vocabulary, we choose to hold fixed. So he has a theory of the goodness of material consequence and incompatibility relations, which nobody had before and practically nobody since. So that point, I think, is just filling in something that was implicit in the story I was telling last time. Something I didn't get around to saying is, officially, though Bolzano doesn't emphasize this, it doesn't come up every time he mentions it, officially, he thinks of these reason relations not as triadic, but as involving four argument places: the premises, the conclusions, the analysis, thought of as a partition of the vocabulary into fixed and variable, and then which substituents do you look at? When you say every substitution for the variable portions that makes the premises true, makes the conclusion true, what substituents are you allowed to put in there? He means, he would like to say, well, it's all the Vorstellungen, all the parts. But he insists there is no such thing as all the Vorstellungen. There isn't because there's no such thing as all the Sätze. And for each Satz, you can form a Vorstellung, it can be a part of other Sätze. Because there's a procedure for taking any set of Sätze and producing another one from it. So, if I have this claim and I say, look, these are all the propositions, and he says, well, what about the proposition that these are all the propositions? That's a thing you could say. You're claiming even that that's a true proposition, but it's not identical to any of the ones that were in the set that you had. It's something new. He says, that means there's an infinite number, but it's worse. It means that there is no definite number, finite or infinite. And distinguishes, he says, look, this isn't a problem for saying there's an infinite number of counting numbers. For any finite set, you can always find one that isn't in it, but it makes perfect sense to talk about all of them, because all of them isn't the successor of any of those numbers. It's not another number. Talking about all the propositions or all the facts isn't just a matter of there being an infinite totality, but you can still talk about the totality. No, you really can't make sense of the totality of them. And on the handout last time, I rehearsed the proposition 1.11. It's the third proposition of the Tractatus. It says the world is determined by the facts and by there being all the facts. Now, Bolzano is saying, look, there's a problem with that. And there is a deep and fundamental problem in the metaphysics of the Tractatus there. What is the status of that claim? These are all the facts, or there being all the facts. That isn't a Tractarian fact. It's not the arrangement of any elementary objects. So it's not something in principle sayable, but it's also not something that's shown in the logical form of the fact in virtue of which it it's pictured by a proposition. That's what he says can be shown but can't be said. But the claim that these are all the facts isn't something that can be shown in Tractarian terms either, for essentially the Boltzannian reason. So officially, when you specify what are the good implications, you also should say, well, which set of substituents, which set of Vorstellungen are you thinking that you can substitute in here? You get to pick any one you want, but you can't just say all of them, because that notion doesn't make any sense. So I find it interesting that he's using an argument that's of the same genus as Cantor's diagonalization arguments. He's not going with that where Bolzano is going, but he sees that there's a difference between these cases. There's something fishy about the notion of all propositions, and so all Vorstellungen. So I just wanted to get that thought on the table. Well, as I said, last time, the context I was trying to put Frege in is Bolzano. I think his thought is interesting in its own right, but also because the central concept is substitution, and though he had made the move to think of functions as broadly as Frege does, he didn't think of it as functional analysis. But what he's talking about is what Frege is talking about with functions 50 years before Frege was. But the context I want to talk about today is really, I think, one of the central concerns of Frege about the fruitfulness of concepts, about the fact that in mathematics you can put together a set of claims and concepts and get something genuinely new out of them. In the Begriffsschrift, his proof of Proposition 133 is extracting a powerful mathematical result that was only proven in the generation of mathematicians before Frege, downstream from the uniform convergence theorem, absolutely substantive. 50 years before, nobody knew this, and he's getting it out of purely logical materials. And on the semantics he inherited from Kant, you couldn't see how that was possible. So on the handout this time, I've rehearsed the focal passage really from the Grundlagen. He says, Kant seems to think of concepts as defined by giving a simple list of characteristics in no special order. Gold is a yellow, heavy, malleable metal, for instance. But of all the ways of forming concept, these are the characteristic marks in Leibnizian vocabulary. But of all the ways of forming concepts, that is one of the least fruitful. Fruchtbar, it's the Kantian term. If we look through the definitions given in the course of this book, she'll scarcely find one that is of this description. And the same is true of the really fruitful definitions in mathematics, such as that of the continuity of a function. What we find in these is not a simple list of characteristics. Every element is intimately, I might say organically, connected with the others. Now here he's talking about what Bolzano called the mode of combination, which Bolzano's examples for why you needed to distinguish them, he said you can have two things that have the same, two zetsa that have the same contents, in that they have the same parts, the same representations make them up, but they make different claims. So, or are just different representations. So two of his examples are an ignorant son of a learned father as opposed to a learned son of an ignorant father. All the pieces are the same, but you're talking about a different phenomenon. He also uses 2 to the 4th and 4 to the 2nd, all the same parts, even the same in some sense, simple predicate, putting them together, but the mode of combination is different. And Frege is saying, yes, and this mode of combination, this is an essential feature of fruitful definitions. If we represent the concepts or their extensions by figures or areas in a plane, then the concept defined by a simple list of characteristics corresponds to the area common to all the areas represented with the defining characteristics. It is enclosed by the segments of their boundary lines. He's thinking of Venn diagrams or Euler diagrams. With a definition like this, we use the lines already given in a new way for demarcating an area, and similarly if the characteristics are joined by an or. Nothing essentially new, however, emerges in this process. But the more fruitful type of definition is a matter of drawing boundary lines that were not previously given at all. What we should be able to infer from it cannot be inspected in advance. Here we're not simply taking out of the box what we have put into it. The conclusions we draw from it extend our knowledge and ought therefore on Kant's view to be regarded as synthetic, yet they can be proved by purely logical means and are thus analytic. And in the long Boole essay, he says, it's the fact that attention is principally given to this sort of formation of new concepts from old ones, the Boolean ways, while other more fruitful ones are neglected, which is surely responsible for the impression one easily gets in logic that for all our toing and froing, we never really leave the same spot. And again, if we compare what we have here with the definitions contained in our examples of the continuity of a function and of a limit and of the ancestral of a relation, we see there's no question there of using the boundary lines of concepts we already have to form the boundaries of the new ones. Rather, totally new boundary lines are drawn by such definitions, and these are the scientifically fruitful ones. Here, too, we use old concepts to construct new ones, but in doing so, we combine the old ones together in a variety of ways by means of the signs for generality, negation, and the conditional. He's thinking of the fact that you can't represent in a Venn diagram, you've got the A's and the B's, and now we want to say, well, for every A there is a B such that RAB. And you can't say that in the language of Venn diagrams, and that's the kind of thing he needs to say. Again, actually very close to the first passage from the Grundlagen in the text, the truth is that the conclusions drawn from fruitful definitions are contained in the definitions, but as plants are contained in their seeds, not as beams are contained in a house. Often we need several definitions for the proof of some proposition, which consequently is not contained in any one of them alone, yet it does follow purely logically from all of them together. Now, this is the problem area that I want to address today. And this is the one that the kite of forms of conceptual novelty starts with logically atomic propositions, and the very first stage is to make Boolean combinations of them. And before I move on to the kind of novelty that he's pointing us to that goes beyond those Boolean things, I just want to mention that we shouldn't disparage what you can get with the Boolean sentential connectives in this regard. You really do get some new things here. It's true that you can represent all of the syllogistic relations in Venn and Euler diagrams. So all A's are B's, all B's are C's, so all A's are C's. The syllogism in Barbara, but Celarent, the EAE syllogism, some A's are B's, all B's are C's, so some A's are C's. You can represent that with a Venn diagram as well. So whatever you can get syllogistically, you can get this. You can get this way. But if we get what Boole gives us, in effect, all the truth conditions, you can get Fodorian productivity or generativity as well. You start with a bunch of microfeatures, as in syllogistic logic, think of them as monadic predicates, and you form all the Boolean combinations of those microfeatures. Well, you get new concepts, new claims, in fact, an infinite number of them. You can negate this one and then conjoin it with something else and negate that and take a disjunction with that. You can generate an infinite number of new concepts and claims from that. Fodor says, look, the Chomskyan observation that we produce and understand an infinite number of novel sentences that have never been uttered before, means that there must be some generativity, some productivity, some recursive generation of these things out of parts. Otherwise, it's unintelligible that we could produce these things and consume them, even though, and this was a Chomsky observation, almost every sentence uttered by an adult native speaker is actually novel in that it's never, that particular sequence of words has never been uttered in the history of the world. That's true of most of the things we say, particularly in academic speak. Unless we're quoting something, it's very unlikely that just that sequence of words has been uttered before, but we can understand them. Well, you get that with Boolean combinations. And for a long time, and you'll still find this in psychological literature, they're thinking, well, to get novel concepts, it's good enough to have Boolean combinations of microfeatures. It blew people's minds when Coco, the talking gorilla, who had learned signs for water and for bird, first saw a swan and made the sign for water bird, putting these things together, and after that used that as a concept. They said, new concept. Well, it is. That shouldn't be disparaged. It's not as fancy a kind or as important a kind of novelty as the kind Frege wants to talk about, but Frege's kind is built on that, and we should appreciate that. Second of all, if you think about the kinds of contents that you can have if you don't have Boolean combinations of them, think about the attempt to put into signs, really into pictures, various prohibitions. We have the international symbol that has a red circle and something with a line through it means none of those. When my son was little, we went to a European park and he said, what does this sign mean? There was a picture that was evidently a dog, but he could see it was a Scottish Terrier, a Scotty from the ears and so on. Does this mean no Scottish Terriers? Or does it mean no dogs? Or does it mean no pets? What actually does it mean? What is the scope of that negation? Could you conjoin those two or disjoin them in a sign in order to say this? No, you need another kind of content than just pictorial content to work and play well with negation, and indeed to distinguish disjunction from conjunction, and so build these things up. Those Boolean combinations are really important. Furthermore, the thing I wanted to know about the capacity of non-human primates, when I had the opportunity to talk with Mike Tomasello, fabulous, important developmental psychologist and primatologist. He's the one who studies the non-human primates and also the development of young children. And what I wanted to know was whether you could teach any of the non-human primates conditionals. Could you teach them that if the red light is on, then there's a biscuit in the bin. You just have to open it to see. Can they master that construction so that they don't, when you say that, if the red light's on, then there's a biscuit in the bin, just go to the bin. Oh, I heard biscuit in the bin, independently of whether the light is on. Or if they do open it when the light's not on, say, wrong, why did you tell me that? General bizarreness reaction to it. Could they master that withholding, understanding that you're not endorsing that antecedent, but saying, in the cases when that antecedent is true, now we're asserting this other thing. The disappointing answer, he said, "Oh, absolutely not. They will never get that. Can't get this story off the ground." Well, to say that they didn't have that capacity is to say they couldn't distinguish force from content. They couldn't appreciate some of these things as portions, though assertable, they could be asserted. They're not now being asserted. They're just there to contribute content to the thing that's asserted. Okay. They didn't have that. That's a crucial ability. What we get for that force content distinction, for the ability to use conditionals, is the capacity to explore the consequences of claims counterfactually or subjunctively. What if this were true? What else would be true? I'm not saying this is true. And of course, young children have a hard time with that, but they eventually get it. And he's saying, no, the chimps are never going to get that. I want to turn the crank one more time and say, okay, this is only, what I'm about to say is only true in a sort of semi-degenerate way for truth-functional connectives, but what you get for a conditional is the capacity to say something about the consequence relations in virtue of which the sentences that are involved in it mean what they mean. That if it's red, then it's colored. That tells you something about the meaning of red and colored. If it's red, then it's not green, telling you these are incompatible things, letting you say that, which you could understand that red and green were incompatible sort of practically, but it's a substantial advance in expressive capacity. You get new concepts and new claims if you can do that. So all of that is to say you are making a substantial step. The Boolean connectives do give you important expressive capacities. There is a clear sense of new in which they get you new concepts and claims. Frege is just saying, yeah, but that's not good enough. You can't get anything really exciting that way. Now, we've already talked about, in Dummett's phrase, the distinction between simple predicates and complex predicates, where simple predicates are parts of expressions, and complex predicates are something like patterns in them. So in order to understand the relation between the relational predicate admires and the property of being a self-admirer, you have to distinguish X admires X from X admires Y. In general, see what pattern is exhibited by Rousseau admired Rousseau, Descartes admired Descartes, but there's no part of those two sentences that isn't also a part of the sentence Rousseau admired Descartes, and yet there's no self-admiration going on in that second case. Frege's logical notation can, as the traditional logic could not, form complex predicates. I mean, the first observation there is, well, the traditional logic couldn't do it because it didn't really talk about relations at all. It only had monadic predicates. All men are mortal, Socrates is a man, so Socrates is mortal. These are monadic predicates that we're looking at the relations of when I talk about Boolean microfeatures. Those are properties that things can have. So we have to step up and look at relational properties in order to distinguish the complex predicates from the simple predicates. And the first thing to realize about Frege's notation is it's set to do that. The complex predicates correspond to functions into which you can analyze different expressions. And I said we can think about those in terms of the equivalence class of expressions that can be, each of which is a substitutional variant of the other, uniformly substituting all the A's for B's and so on in them. So that's the level that Frege is clearly invoking, a kind of novelty that you get with complex predicates. As I say, this isn't new, but I want to emphasize an aspect of it. If you look on the handout, I guess, at the top of page 3, so first we can put together some simple expressions and get so the capital letters are supposed to be relational expressions, and the singular terms come after them. These are the simple predicates. But now we're going to go through and do a functional analysis of that. We start with these, and now we can compound them. And we get new sentences in the Boolean sense of new sentences. We applied sentential operators to those logically atomic sentences. So this is composition, as voters said. We've got to think of what we're doing as compositional or generative. But now we can go through and analyze this. We can decide to treat some of these expressions and now we've got a new predicate that we didn't have before. This is the productivity of the predicates. This one we're thinking of all the ones that were B's in here. We're going to look at all the substitutional variants of this. This is a new complex predicate, and it's new in a new sense. It's not just gotten from these things by Boolean combinations of them. We had the composition, And then we have the decomposition of it. We carve it up into a function and an argument. But this function, this is a one-place predicate now. What RAXSXC, this is a one-place predicate in X. And it's a predicate that we didn't have before. It's not a predicate that's exhibited by any of these. Well, you can see it as exhibited by this, but only by doing the functional decomposition of it. And now we can put a quantifier onto the front of it and make the claim for all x, RAX, and SXC. That's a new claim that we couldn't make before, that we got by this two-phase process, composition at the sentential level, and then decomposition by functional analysis. And the quantifiers takes us back to get a new sentence. And we can do this forever, because now we can take this and disjoin it, say, with, let's say with the original sentence, and now we can come through and do a functional analysis on this thing, treating the C as variable in this. Now we get a new one-place predicate in Y. We bound the quantifier in X, but Y is open. This is a new property that things can have, being such that if it's related, I don't have an example to go with this. But what Frege gives us is a two-phase process, combine things Booleanly, sententially, decompose them functionally, and then use the quantifier to form new sentences which you can continue to analyze this way. And more than that, if you take an expression like this, or what we get, the sentence that we get, if we put a quantifier in Y at the front of it, the astonishing thing is, he gave us a procedure for computing the inferential role of sentences that are produced, of arbitrary sentences that are produced by this inhalation and exhalation, this putting together and taking apart. Basically for the quantifiers, you know how it works. If it's an existential quantifier, we get a disjunction of all the substitutional instances. That's inferentially equivalent to the existential quantifier. If it's a universal quantifier, we do the conjunction for it. It's easy to say what the consequences of those things are. So if we want to analyze some complex thing, we just decompose it in the reverse order that we built it in. So interpret the outermost quantifier, you get an equivalence, it's a conjunction or a disjunction of things that don't have that one, then do it with the next quantifier, and eventually you'll get something that explains the meaning of this in terms of a bunch of things at the level of these sentences. So what Bolzano never did, what Boole never did, is give a procedure where, on the one hand, you could build to the sky with genuinely new properties like this that let you make new claims like this and keep complete inferential control over them. You still know exactly what follows and what's incompatible with each of these sentences. There's a mechanical procedure for computing that. He did all of that in the Begriffsschrift. And nobody could see it. Nobody could see why this was an achievement. So here's a real sense of new content, of getting new concepts out of old concepts. And he wants to say the theories that people have had, well, the theory that Kant had, because that's the high end of this, of content, didn't explain this kind of fruitfulness of novelty. This is something genuinely new under the sun, in a new sense of new. Well, he's saying the mathematicians were already thinking this way, but they couldn't understand the contents that they were manipulating in the way that Frege gave us a perspicuous notation for. Okay, so, I had talked about what Dummett calls the distinction between simple and complex predicates, and that's basically all you need to know to understand this, but I wanted to extract this particular consequence. All of that's really just to get me to my topic today, because the most interesting thought about fruitful concept formation, ways of forming new concepts and claims, I'll say, from old ones, that produce new results in ever more demanding senses of new. In the way that this formation by composition and then functional decomposition incorporates but goes beyond the kind of novelty that you get just with the sentential connections, sentential compounding operators. So here, to think about this question, I think we have to go back to Kant. And what I see as one of Kant's most basic thoughts, or most basic questions, really. And that is, in the Grundlagen, in that passage, it goes over from page 1 to 2 on the handout. Often we need several definitions for the proof of some proposition, which consequently, the proposition is not contained in any one of them alone, yet does follow from all of them together. Okay, he's interested in what follows purely logically. The question I see exercising Kant is, how are we to understand in general the possibility of drawing a conclusion from a set of premises that contains things that aren't contained in any of the premises? The entire tradition that is culminating in Kant thought of the content of a claimable. The content is what's contained in it. And we could have different models of that, the characteristic marks of things, for instance. But it is possible, if we look at multi-premise inferences, to get conclusions that contain things whose content is not part of the content of any one of those, or even all of them if you put them together. I mentioned Bolzano uses the term content for the parts of Sätze, but he says they can have the same, and so we can have the content of all of the premises, but we've got to also care about the modes of combination of them if we're going to get something that has a content as a consequence that isn't part of the content of any of the premises, even the union of all of the parts of those premises will not tell us what's in it. And this, I mentioned we need to think about polyadic predicates, not just monadic ones. Now I'm saying we need to think about genuinely multi-premise inferences, not just single-premise ones. And here, one way of understanding the criticism that was old hat by the time Kant was writing of syllogistic, that it was sterile, it was precisely not fruitful, you only took out what you had put in. One way of understanding that complaint is, the conclusion has as its content something that is part of the content always of the major premise. All men are mortal, we're going to get the conclusion, Socrates is mortal. Well, that conclusion already has that as part of it. You could think of it as the conjunction of Socrates is mortal and Aristotle is mortal and Plato is mortal and so on. And we're just picking one of those. All the minor premise does is tell you which one to pick. Another way of thinking about it is the major premise is a rule of inference, and it already contains all of its instances. Syllogistic logic on this account is not just restricted because it's monadic, it's essentially single premise inferences. That's disguised by its having different minor premises, but basically it's a single premise inference. But ordinary reasoning isn't like that. If I say, John left his house at noon, he's walking, he walks about 4 miles an hour, and where he's going is about a mile away, so, conclusion, he should arrive around 12:15. Now that conclusion, he should arrive around 12:15, that's not in the claim that he left at noon, it's not in the claim about how fast he was walking or how far it is. You have to put all those together in order to get that conclusion. I mean, that reasoning is nothing like syllogistic. Syllogistic reasoning doesn't help you with an inference like that. So it's not going to help you with, inferences in Newtonian mechanics, where, we're just even Galilean unpacking of the so many miles per hour and so many miles and so many hours. What is it? Even that reasoning is not syllogistic. It's essentially multi-premise reasoning in a way that syllogistic reasoning is not. And Kant's question is, how are we to understand that? How are we to understand the possibility of the group of premises containing something, the conclusion, that isn't contained not just in any one of them, but even if you put the pieces together, the Boltzanian content that is the union of all the parts of those still doesn't get you this conclusion. We need another semantic model. And I say, this is the entire tradition, right? From Aristotle to Leibniz to Kant himself, the young Kant, as we're looking over his shoulder, asking this question. We need a new model of content to handle essentially multi-premise inferences, which syllogism is not addressing. And Kant has, of course, I want to say, a radical and original response to this question. He says, well, you can't get the conclusion or the content of the conclusion of a genuinely multi-premise inference just by summing the contents of the premises. That's a way of putting together those contents that won't get you all the conclusions that genuinely follow from multi-premise sets of premises. So, he says, there must be another way of putting them together that isn't simply summing them. There must be a way of putting together those premises to form a new kind of whole from them. A whole that has a content that isn't, in that sense, reducible to the contents of any of the things you put together. He says, that way of putting them together, I shall call synthesis. That's the synthetic way of putting these together. It's synthesizing them so as to make a new whole. New in the sense that it contains things that aren't contained in any of the premises, even in all of the premises taken severally. If you union all of the Boltzannian contents, you still don't get what's contained in the premise. So this whole, when you've synthesized the set of premises, when you put them together in this new way, which I can't now need a theory of, but this is the form of a response to the question, how could there be content in the conclusion that isn't in any of the premises, or even in all of the premises, if we just gather together those contents without doing anything to them? So, well, there's another kind of doing, and it produces a new kind of unity that is not just the mechanical sum of the contents you had. It's a synthetic unity, a new kind of unity. Now, he's going to give us a theory of that synthetic activity, of how you have to put things together to count as synthesizing them so as to get something new. And downstream from that, he's going to make remarkable claims about the kind of unity that is produced by this synthetic activity, which is of the essence of our mental rational capacities. One of them he's going to claim is this is the very form of awareness. This synthetic unity is the kind of unity characteristic of apperception, of being aware, not in the sense of being awake, but in the sense of being able to think and say that things are thus and so. So that's a big job for this notion of putting contents together to get something new to do, to understand the synthetic unity as the kind of unity characteristic of apperception as such, of awareness. Sapience rather than sentience is going to be understood in terms of this kind of rational capacity. More than that, he's going to claim that this unity characteristic of apperception, which is a synthetic unity, so far this is just a black box notion for us, right? This notion of synthesis. We're looking at the jobs he's going to call on it to do once he has an account of it. He says it's not just the kind of unity characteristic of apperception, it's also a transcendental unity. It's in terms of that kind of unity that we're to understand the representational dimension of the things that we unify synthetically. The fact that they are, as it were, of or about things. Tanquam rem. Now, I'm not going to talk about the understanding of apperception in terms of synthesis, never mind the transcendental dimension, the representational dimension of synthesis. People have, I think, been misled in trying to go back and understand synthesis by thinking about those things. But it's more basic than that. And at base, it's his answer to the question. How can we understand the possibility of premises leading to a conclusion that has a content that isn't part of the content of those premises, taken severally or put together in a mechanical or reductive way? And his answer is, interestingly, a kind of pragmatist answer. There's another kind of doing. There's another kind of putting them together. And to take a bunch of things as premises from which to draw a conclusion, that's got to be a paradigmatic exercise of this synthetic ability. I'm going to say this I think is not a common way of thinking about the structure of Kant's thought, but I think this is the way he got where he got. And one way of seeing that is he was, as many people were, but particularly driven by this question and by the idea that there must be another way of putting these things together. So far just a label, synthesis, for doing it. He's struck by the contrast between syllogism, which only does take out what you've put in before, and Euclidean geometry that starts with a few basic notions and proves all these initially surprising results from it. He says that must be a paradigm, at least if we could understand that, then we could get a handle on synthesis. And Kant spent a couple of years thinking intensively about how arguments work in Euclid's Elements. Now, I don't know if any of you have ever thought hard about Euclidean geometry. I certainly never had before having this sort of motivation to think about it. But here's, as it were, what Kant had to work with as he's thinking about it. The very first proposition in Book 1 of Euclid's Elements, we start with 2 points. Now, Euclid has set it up so there's 2 things we can do with a pair of points. We can draw a line through them to form a line segment, and we can treat one of them as the center of a circle and draw the circle where the radius is determined by the other one. Drawing a line connecting them, that's like using a straight edge. Drawing a circle, that's using a compass to draw the circle. Right? Basically a string with that length that you go around it. This is why the question of what can be constructed with a straight edge and a compass is the form of geometry problems, anyway, a species of geometry problems in Euclidean geometry, because that's all you can do. You don't start off with anything about triangles. But proposition 1 says, yeah, but this is all you need in order to construct an equilateral triangle with this as the base. First of all, you form this line segment, then form this circle, and now take this point as the center of the circle and this one as on the radius, and form that circle. We've got a point of intersection of them. Well, there's chit-chat going on in the background for him to get that. Now draw this line. It's a radius of this circle, so it's the same length as AB. Now draw this radius, so it's the radius of this circle, so it's equal to AB. One of his axioms is things equal to the same thing are equal to themselves. So all three of these are the same length, so that's an equilateral triangle. Now, our original talk was about drawing a line segment, drawing a circle. It just didn't have anything to say about triangles. Now we know for any line segment how to erect an equilateral triangle with that as the base. So we know that there is such a triangle. We can show you how to find it. In some sense, that triangle had to be contained in what we started with, which was just these practical capacities to connect the lines. And we got an existence claim. There is an equilateral triangle there. If we jump to proposition 10 of book 1, we do the equilateral triangle that goes to the other point of intersection and construct the midpoint of this line segment. I mean, obviously you need some other things. That's why what happens in between proposition 1 and proposition 10 to get that this is going to bisect and that those will be right angles as well. Eventually we're going to get exciting things like that the angles of a triangle always head up to 2 right angles, that the medians of every triangle intersect in a single point. Exciting stuff that is not obviously contained in the things we have there. But proposition 10, it shows that it's another existential claim, every line segment has a midpoint. But that means if AB does too, then so does AE. It has a midpoint, and it does. So there's an infinite number of points on each line segment. An infinite number of points on the line segment. We're getting a claim about how many points there are on a line just from being able to draw the line segment and the circle. This is getting new stuff. No question about that. But what is, how is this trick done? In some sense, there can't be anything hidden here. It wasn't that he snuck the rabbit into the hat when we weren't looking. It could not be more transparent. The argument in the opening of Euclid's Elements. And as he's looking at this, Kant sees, as Euclid gives us the clue. Sorry, I'm not going to get the Greek word without. Yeah. A Euclidean demonstration has two parts. It has the construction, the kataskoia, and the discursive argument, the apodeixis. So, for instance, the apodeixis for proposition 1 is, given that A is the center of the circle CDB, AC is equal to AB. Given that B is the center of the circle CAE, BC is equal to BA. Given that AC equals AB and BC equals BA, we can infer that AC equals BC, because what are equal to the same are equal to each other. Given that AB, BC, and AC are equal to one another, triangle ABC is equilateral. That's what you can write down. That's the apodeixis. But it depends on the kataskoia. It depends on the construction. It depends on the ability to do these two things. To draw a line segment connecting any 2 points and draw a circle that has one of them as the center and the other is marking the radius. So, he says, Kant says, how important synthetic work in putting together these premises in order to get something new out of them, the concepts we can think of as being point, line, and circle that we started with, about which we knew very little, but we knew any 2 points determine a line, any 2 points determine a circle in these 2 ways. We start with that and we get the notion of triangle. We get an existence claim that depends on the construction, and we get claims about infinity, but infinite consequent, which again are not contained in the things we started with. So the clue, he says, synthesis must be on exhibit in Euclidean argument in the constructions. In the apodeixis, we really are just taking out what we put in. 2 things that are equal to the same thing or equal to each other. That's sort of logical in a syllogistic sort of way. Instantiating a principle like that. The work that's getting us the new stuff is happening in the construction. So he's got a question: how are we to make sense of a bunch of premises implying a conclusion whose content is not contained in any of the premises, individually or severally put together in this other way, put together in an analytic way. And he has his form of a response: well, there must be another way of putting them together, synthesis. And now he's got a clue. I've got an example of synthesis in action in the proof structure, the argument structure of Euclid's Elements, where I can see what's going on that isn't merely analytically putting the pieces together, is happening in the kataskoia, in the construction. Now, this has important consequences for the way he understands basic rational capacities. We need a synthetic capacity. Now, this is background for Frege's achievement. That's what I'm hoping to shed light on here. Here are two observations about this. One is, and this is directly relevant to Frege, the claims that we start off with, we could write as for any 2 points, A and B, A and B, and they are points. A is a point, and B is a point. You got that. But what's true is that for any AB, there is, well, a line through them. There is a circle with the one of them as the center and the other. The main point is, these claims, it's a for all there is, alternating iterated quantifiers. For this one, for any 2 points, there is a point between them. Well, it follows from that there's an infinite number of points between them, because we can repeat that for here. Kant wasn't in a position to see that the character of the claims that lets you get existential claims, there is something. Well, that's existential quantifier. But to get that with generality so that you can construct, for any of these things, there is one of these, not just in this case. And that if you've got that, then you can make claims like for any 2 points there is a point in between them, and that's enough to say, to conclude there's an infinite number of points. So Frege can say, your synthesis, your way of putting things together is just forming complex predicates from them and having alternating iterated quantifiers. The key to synthesis is that. And that's what was missing from syllogistic, working as it was only with simple monadic predicates and, in effect, only with single premise inferences. Well, that was really all you could get if you started with that. So that's a story about Kant's question, his brilliant sequential response to it. Question, how are we to make sense of a group of premises containing something, having implicit in it, in the literal sense of implying something, that has a content that is not the content of any one of them, or even all of them put together, if we just Booleanly put them together, if we just mechanically union those contents. And he says, well, there must be another way of putting them together synthetically. And taking his paradigm of a kind of reasoning that does that in Euclid, and conjecturing that if you could construct things in a generalized form like Euclidean constructions in the imagination, that you could make sense in those terms of all productive inferences? Well, without having the quantifiers, he could see that if you can handle iterated quantifiers like this, see the iterated, you don't really get anything new if you have a bunch of repeating quantifiers, because you can just run those variables together and quantify over tuples. And similarly, if you have repeated adjacent existential things, well, that's just the existence of a tuple rather than those. It really is this combination. I mean, iterated the other way because of the way the negations work, but this is the one that he's focusing on. Kant conjectured that if you could just get these, you could get everything. Everything that Euclid has, and crucially, everything that Newton needs. I mentioned that one of Kant's moves is to move from Aristotelian principles of identity and individuation in terms of substances and their essences and accidents to essentially Newtonian modes of identity and individuation according to spatiotemporal location. Well, that meant that in order to talk about ordinary empirical descriptive things, in order to understand the content of ordinary empirical descriptive concepts, we have to be able to make sense of space and time as continuous, at least as dense. He's not in a position to make that distinction, as continuous media. How are we going to do that conceptually? Well, it's part of synthesis. It comes from synthesis that you can talk about the infinite subdivisibility that's characteristic of space and time that you can do calculus in. Kant could see that. I mean, he conjectured, could he know? But he was confident that you could get everything you needed, not just for Euclidean argument, but for Newtonian argument, if you just give him synthetic abilities that we retrospectively, looking back from Frege's point of view, can see just amount to having the for all there exists iterated, alternating quantifiers. I mean, this is an astonishing conjecture on his part. And look, he turned out to be right. At least you can get everything that first-order quantificational logic with identity gives us from that. He was right. I mean, he was doing it in this clumsy way because the Euclidean model sort of tied him to the notion of these constructions in imagination. You had to actually be able to draw the line that had the successor of the previous point and extend the line to get all the numbers, trying to elaborate the mathematics of his time from that is no small job of work. But I'm saying, essentially, it can be done. Frege did it in the quantificational form rather than the drawing lines in the imagination form. Okay, now here's a conceptual move that I am just in awestruck admiration at. Understanding the relation between Kantian synthesis and Fregean quantification. I mean, I should say, Frege did more than this and gets more than just this. And Macbeth is very good on this in the first book, but he got all of quantification. I mean, he did the higher order things too, could reason about functions, and that matters, but I'll get back to that later on. And this is the observation by Jaakko Hintikka and Michael Friedman that another way to get everything you can get with alternating iterated quantifiers is with Skolem functions. So Skolem's working in, I think, flourishing in the 20s of the 20th century, logician. And he has, so he's downstream from Principia Mathematica. He's got, you know, our notation that we would use for these logical things. But he sees that everything you can get with for all x, there is a y such that Rxy, so there's a you could get, if you just had a function associated with R, which if you give it an x, will return a y as the value such that x are y. To say that for all x there is a y, Rxy, just says that if you take any x, there is some y that stands in the relation R to it. And you can do that by having a function which, given any a, the universal quantifier goes here, give me any argument, and I'll return as a value the y such that Rxy. You know, once you have this idea, it's just sort of mechanical calculation in order to translate these things into Skolem functions. Skolem cared about this because the Skolem functions are constructive. This one just says there is something, whereas if you can write the Skolem function for it, it tells you how to compute the y that stands in the relation R to any x that you put in there. And the Hintikka-Friedman observation is that's the missing link between Kant's notion of synthesis and Frege's alternating quantifiers. Is Kant thought of what you had to do, the synthesizing that was producing the new whole, the new kind of whole. He thought of that as, well, synthesizing is applying a Skolem function, actually producing the triangle or the midpoint. What Euclid did was give us a procedure for taking any one of these, any pair of points, and producing a midpoint or an equilateral triangle. And if we think about that Skolem-wise rather than Frege-wise, we get something very close to what Kant did. The only way Kant could think about this was sort of geometrically. He abstracts from the geometrical, and you're not literally drawing lines, but it's an ability like that. And one of the questions is, well, sort of, what's the commentary on that model? What things carry over from the one to the other? But the essence of it, what makes it work, is the synthetic abilities are embodied in Skolem functions. And I say, to see this about what Kant did, to see both that he got the effect of not just forming complex predicates, but particularly this quantification structure of them. Not only that, but that we can understand his notion of synthesis in terms of Skolem functions. Take the apodeixis of these, and if you add Skolem functions to them, then you can formalize these arguments. Show them as purely conceptual, the way Frege said they were. So this is why I described the idea of the Skolem functions as the missing link between what Kant did downstream from his years of thinking about the argument structure of Euclid's elements and the Fregean version that we would do, that gets us existence and infinity if you just iterate the Skolem functions. So, I think never mind the moves that Kant made, which are awesome in their own fundamental right, just as a hermeneutic move to sort of understand what's going on in the relation between Kant and Frege in the way that Hinteke and Friedman do, is just a fabulous move. I mean, it is so illuminating, it seems to me. Okay, it's 2:27 when we take our break and come back at 2:42. Okay, well, I hope that was an illuminating story, and that you can see why I thought of it as belonging with placing Frege in context. I mean, it's context going all the way back to Euclid, to Kant, but also non-trivially looking back from Frege's quantification and indeed from Skolem and what just in the last decades Hinteke and Friedman were able to say. But at this point we should go back to the original question. How are we to understand essentially multi-premise inferences? And I mean here, reason relations generally because it's implications and incompatibilities both, but I'll just talk about the implications and talk about the inferences. So, does the fact that there's a clear way in which you could put together the contents of the premises and not find the conclusion among them, even implicit in them, in any ordinary sense of implicit. If you just sort of gather together, union the Boltzanian parts of them, you don't get something new in the sense that multi-premise inference can give us something new. And Bolzano says, well, that's because the modes of combination matter. And Frege says, for the real arguments, where you do get something new, the premises you're putting together are not just sort of separate, independent items. They're all intimately related to one another. He's going to say, well, the definitions have to be in terms of some of the same concepts in order for this new form of combination to give us something genuinely new, for the synthesis to do it. And Bolzano says we have to understand those modes of combination in terms of the relation that each sentence, I'll say sentence instead of proposition, stands into other ones. And those are broadly substitutional relations that it stands in. we see how he gets consequences out of it. And notice that for Bolzano, we can understand how a set of premises can have consequences that none of the premises have individually. What we're saying when we say that the set of premises gamma implies A relative to a functional decomposition is that every set of substitutions, every set of substitutional variants of the premises that gets us all true premises, that same set of substitutions will get us a true conclusion. So he's got a sort of story about that. But still we can ask, how is the trick done? And how's it even done in Euclid? What is the source of the new things? How are we to think about the content of, for instance, a line segment, so that the line segment can, even though it doesn't contain triangles and midpoints and the infinity of points when we just put that out there, how is it that that content together with the content of other things can add up to something more, or can produce something that's new in a sense that just adding them up wouldn't do? And here's how I think it goes. For Frege, if we think about an expression like that, the different functional analyses of it correspond to, well, treating this as an argument and seeing the argument F4 applied to 2 to get 16. If we think of that as the argument, we're thinking of this as an argument, 2 down there, applied to 4 to get 16, or think of it as applied to 2 and 4, different function to get there. In one way of analysis, this is playing the role of an argument, and the 4 is just part of the function. In this one, the 4 is the argument, the 2 is just part of the function. In this one, they're both playing the role of arguments, and the function is indicated by the arrangement of them. The parts can be thought of as combined in different ways according to different analyses. Or put another way, the parts play different roles according to different functional analyses of them. That's the key for Frege, because each one of these decompositions, each one of these analyses corresponds to a pattern of inference. We know that if we're applying this function, the raising to the 4th power, to anything, it's going to be equal to x times x times. I shouldn't have picked x, should I? It's going to be equal to the product of the argument with itself 4 times. Whereas this one, it's going to be raising 2 to the power of the argument, so it's going to be 2 times 2 times 2, well, y times, if we're applying that to the thing y. So these are different inferential patterns, this identity licenses a different set of intersubstitutions than this one does. Each of these modes of presentation that correspond to a function applied to an argument that make up the sense of that expression, each one of them corresponds to a different pattern of inferences involving the thing, a different thing you could understand by it. And the fact that they're all analyses of the same expression tells you that this expression stands in all those patterns of inference, that it's sort of the intersection of those patterns of inference. So grasping its content is relating it to the other sentences that it's related to by this pattern, the other sentences it's related to by this pattern, in an inferentially controlled way. Each of those equivalence classes of substitutional variants licenses different conclusions from it. And the fact that those are all modes of presentation contained in, Frege says, the same sense, that's the content of it, and that and it means that the thing whose sense that is, you can reason about it in any of those different ways, which are different ways. There's something sort of synthetic about the connection between those. Remember Macbeth arguing that one of the virtues of the Griffschrift notation is that it displays all of those substitutional affinities and so patterns of inference in a perspicuous way. How does the Euclidean argument work? Let's just think about proposition 1 and the equilateral triangle as something new that comes out. What's really happening, the essence of the geometric argument, is if we think about this line segment, A to B, it can just be a line segment, the line connecting A and B. That's one role that it can play. We're told that if you have 2 points, they can play the role of determining a line segment. But it can also play the role of the radius of a circle with center A. That's another role that that line segment can play, that relates it to a whole bunch of other different points. And furthermore, we know some things about lines. You can sort of extend them. And we know other things about circles, about their intersections and the length of, to begin with, radii of them, but then chords of them, and so on. But at the end of the construction, that segment is also playing the role of the base of a triangle. And it's the connection of those and the fact that the very same line segment that is the segment connecting A and B can be the radius of a circle and can be the base or the base of a triangle. The fact that the same line segment can play all those different roles, that's what makes this argument work. That's what makes it productive. If we think about the points, this point can be the end of a line segment, it can be the center of a circle, or it could be a point on the periphery of the circle, the end of a radius, or it can be the vertex of a triangle. We're seeing that that one part, that one component can play all those different roles in the way that the argument of a Phrygian function can play all those roles. Those are patterns of inference. Well, so are these. Different things follow from being the vertex of a triangle. We'll find out, well, that if you connect that to the midpoint of the opposite side and so on, you'll get a single point in there. It tells us that that's, when we've elaborated further, that the sum of the angles of the triangle here will be 2 right angles. That, if we extend this, throw them in, So from its being the vertex of a triangle, different things follow. Then from its being the center of a circle, different things follow from it being on the circle, and different things follow from its being the end of a line segment. It's the fact that the parts can play these different roles, each role being inferentially significant, underwriting a different pattern of inference. That's exactly the same thing that's going on in Frege. He's got a notation now for this, the functional notation, which is a generalization along one dimension anyway of Bolzano's. They say Bolzano hadn't generalized the notion of function in a way that he could, so he just talks about substitutional things. But the point I want to make is it's the same thing going on here. The parts can be are seen as playing as being combined in different ways. It can be combined in the triangle way, or in the circle way, or in the line segment, or in the line segment way, each of which has a different inferential significance. That's how it is that a bunch of premises can have content, can contain something that no one of them contains, or that even just laying them alongside each other, the whole set of them doesn't contain, because we can see across the different premises the same part recurring and playing different roles. What it is for it to play different roles is to think about substitutional variants of it. Well, think about the point as a vertex of a triangle. Well, that goes into a box with all the other points that are vertices of triangles, and what we can say about the triangles, about them in relation to the triangles, or them in relation to the circles, or them in relation to the line segments. But each of these arguments goes by one component playing now one role with respect to other things, and now a different role. And that's exactly what the substitutional functional decomposition characterizes. So the answer, I think, emerges from this to Kant's deep question: how are we to understand the notion of content so that a bunch of premises could have a content or give rise to a content that is not contained in any one of them? The key is, well, they have to have some parts in common, and we have to be able to think of those parts as playing different roles in the different premises, where the different roles are inferential roles, but we get to those by assimilating them to an equivalence class of substitutional variants, each of which can be turned into the other one in the Fregean version. But what makes for productive multi-premise inference, by contrast to the old bad syllogistic, is that the premises have parts that are playing suitably different roles in the different premises, and we're combining them in a way that says, oh, but it can be the same thing that plays this role in the one premise and this role in the other premise. And that's synthetic. That gives us something new when we say that. Even though what holds together the different modes of presentation in one Zin is just that they're different ways of analyzing the same expression, that is, of assimilating it to substitutional variants by treating some parts of it as fixed and other parts as variable. And Frege is as interested as Bolzano is in considering all the ways of doing that. But I'm saying you can understand what's going on in the Euclidean arguments, the paradigm of productive but still purely rational argumentation, as a matter of the overlap of these roles in some part that is playing both of those. If you just think about the line the 2 points as the endpoints of a line segment, as the center and periphery of a circle, as determining the side of a triangle, it's the fact that the same thing can be all of those. That's what construction always does. You don't get any Euclidean argument unless some bits of it are multimodal in that way, are both the side of a triangle and the radius of a circle and the endpoints of this line segment. The point is both the center of a circle and the vertex of a triangle, and later on we'll introduce other conceptual novelties like squares and rectangles. But we only start with line segments and circles. This, it seems to me, Frege gives us, and in many ways Bolzano already gives us, a decisive and illuminating answer to the question that was driving Kant. How can we think about the content? And you have to think about it holistically. You have to think about the content as a matter of comparing it to the content of other things. But because that content can play a role in different classes, different comparison classes that we generate substitutionally, the fact that it's the same one that's playing these two roles, and in one case it's related to, so the point is related to this other point, both as ends of a line segment, as center and radius of the circle, and so on. That's where the new content comes from. It is in the premises, but it's only in the collection of them. It's in the, as it were, cross-references of them, and we can only understand the cross-references and how the fact that one bit of it is playing multiple roles can lead to something new. We can only understand that if we understand the roles that they're playing in terms of their relation to different items at the same level. Now, this observation Macbeth makes in the second book. If you read her chapter on Euclid, you'll see the emphasis on the multiple roles that each geometrical item plays in relation to other things, to triangles, to circles, to lines, and so on, explicitly analogized to the Phrygian and Bolzanian decomposition here. I call that the Macbeth point, because she's the one who taught that to me in this book. And I want to say there are these two ideas. The Hinticke-Friedman understanding Kantian synthesis first in terms of alternating quantifiers, and then understanding those in terms of the work that we would normally do with those being done in terms of Skolem functions, which brings it much closer to the uses that Kant makes of synthesis as an activity, but also ties it to the Phrygian picture, which for him is more basic than the quantifiers, right, is the functional analysis of it. And to see in the sense I've been trying to lay out just in these last few minutes, to see that as exactly what's going on in the Euclidean arguments, that is what, in virtue of which traditional Euclidean arguments could be synthetic, could be productive of genuinely new kinds of concepts. And I want to say, these two ideas are paradigms of why we do philosophy and what doing it well is. The reason to do it is because you might have an idea like this, and it would make all things worthwhile. But the only way to do it is to, immerse yourselves in examples of moves of the kind you would like to be able to make. But I claim both of these are like that. They're clear, and you come away understanding something important that you didn't understand before. Okay. Well, obviously that's sort of the main place I wanted to get to here. We've only done half of the kite at this point. If you remember that picture or look at the plan outline at the beginning of this, there's one limb, one dimension of new notions of novelty that you get to, just to briefly rehearse it, you get something new with arbitrary Boolean combinations of sentences. You get that's productive. There's an infinite number of new propositional claims you can get that way. You can get the distinction between force and content. You can be able to codify relations of implication and incompatibility, even if the way classical logic does that is not very expressively powerful. The only sense of good inference it characterizes is the one in which it's a good-making feature of an inference if it doesn't have true premises and a false conclusion. Well, that's a pretty low bar to cross, but the implications that have that feature are better than the ones that don't. That's for sure. Using a substitutional scalpel to get to discern complex predicates and being able to, so you get new predicates that way, and then can get new sentences by putting quantifiers onto them, combine them with the Boolean apparatus, and you get the whole of quantificational logic. But in particular, you get something new when you have for all there exists, when you have these alternating quantifiers. And what you get is the capacity to codify these different patterns of inference, the different roles that an expression, a sub-expression can play in an algebraic expression that we functionally decompose, or that a geometrical figure or part of a geometrical figure can play in a whole lot of other geometrical figures. I said 90 minutes ago, I don't know whether you'd ever thought about how arguments go in Euclidean geometry. There's more going on there than you might have thought. It's people found amazing things by focusing on that achievement. Plato did, even though he only had the sort of pre-Euclidean version of it. It was his students who taught Euclid in the academy. And by the way, Euclid then founded the museum. Did you know it's not just the academy, but the museum in Alexandria, which was their cultural institution where people like Euclid could do their work. And we've taken that word over too. Anyway, so sort of climbing up the one side of the kite, one of the ways we can see the productivity, the ampliativity, is a word often used in the literature for this, the capacity of modes of combination of concepts and claims to get you new concepts and claims in ever more demanding senses of new. That's what I've been talking about here. But there's another limb. Is it on a par with this? Probably not. But we know another way to use functional analysis to get new concepts from old ones. We know because Frege taught us in the Grundlagen. Abstraction is a way of getting new concepts from old ones. And it's not essentially a quantificational matter, though it does use that. If we start with a relation, RAB, that's an equivalence relation, that's reflexive, symmetric, and transitive, then we can introduce new expressions. So we've got RAB, things of that form, and we can introduce f of A on the condition that f of A equals f of B, just in case RAB, the direction of line A is the same as the direction of line B, just in case A is parallel to B. Now we've introduced the new sortal kind term, direction, and singular terms formed by definite descriptions from it, the direction of line A. Well, we had lines standing in relations of being parallel. Now we have directions and particular directions of lines, so singular terms and sortal kinds, that we didn't have before. And we did that by converting a relation into an identity, the language that Frege uses. Now we have those functions, direction of or successor of. We have functions that the fourth power of is another function that we can have here. And we can turn that crank one more time. Because anytime we've got a function, we can introduce new objects as the courses of values of that function. So we say the course of values of the function direction of is the set of objects such that the course of values of this function is the same as the course of values of that function, just in case they have the same values for the same arguments. That is, we're just turning the crank on that abstraction machinery one more time. So we're going to look at things, the course of values of the object, the course of values that corresponds to that function is something, the graph of the function, it's something like the set of pairs of lines and their directions. But that's a new kind of object, the course of values of that function. It's a higher order sort of thing that's telling us something about the abstraction operation because it's relating the lines and their directions, but now in the form of the graph of the function rather than the function. Well, what are we to say about that way of introducing new concepts and claimables from the old ones? Well, one thing we can say is it for sure gets us new stuff, because in mathematics, real analysis is what you get if you treat functions as objects. If you treat them as the items that you're starting with and look at relations between them. So, for instance, one can be related to the other as the derivative of that function, or as the integral of that function. That's a relation between functions, and it's the higher order functions that are studied by real analysis. And Frege is giving us the notation and the conceptual apparatus for talking about those. And this goes beyond first order quantificational logic, which is what's on the other limb of the kite there. This moving up by abstraction and treating the objects and functions at the lower level as themselves arguments for new kinds of functions. And it's that expressive capacity that enables Frege to do justice to 19th century mathematics, not just the mathematics that Kant was looking at, to be able to talk about things like group theory in his notation. And the arguments that he really cares about, that argument for Theorem 133 in Part 3 of Begriffsschrift, that's what happens when you combine the notion that one thing can play multiple roles, which was the lesson of that its content can consist in the multiple inferentially significant roles that it plays in relation to other things, the different modes of presentation as functions applied to arguments that are contained in the same sense. But now when we combine that capacity with the higher order capacity to abstract and treat functions themselves as arguments and values of functions, and so on, though actually we only go up about 3 levels in the stuff Frege is analyzing. And we'll see at one point he says, actually, it doesn't seem like a lot of new stuff happens when you go up farther than that. Category theory would beg to disagree. That was, that sort of remark was the product of historically blinkered view of the mathematics. The mathematics hadn't gotten far enough to do stuff that was much higher order than he could reconstruct that way. And I mean, Begriffsschrift in principle can go on up. I mean, he had problems with consistency, as we see when you go on up, but conceptually, it was. So at the top of the kite, there's another form of novelty, another sense of new that you get to if you combine the alternating iterated quantifiers, a point about senses and functional analysis and so on, with the hierarchy that you get by abstraction and that way of introducing new things. And the kite there was meant to be an initial rough botanization of senses of conceptual novelty, tagged by the procedures that you apply to an old set of concepts in order to get a new set of concepts. And I should remind you on the side of abstraction that having introduced Bedeutungen as abstract objects by the principle that two expressions have the same Bedeutung, just in case substituting one for the other never alters the truth value of any claim that they appear in. So that's purely by abstraction. The Bedeutung of X is like the direction of X, introduced by abstraction. And then he tells us, and the Bedeutung of the word Fido, the name Fido, is the dog. It's Fido. The Bedeutungen of ordinary expressions are the things we talk about with them, the ones we're representing by them, so that the Bedeutungen of ordinary empirical descriptive vocabulary is just the stuff that's in the empirical world. Well, Fido is not an abstract object. He's as concrete as it gets. If you don't believe it, let him slobber on you. Abstract objects don't slobber. That's a fundamental principle. So some expressions can be introduced by abstraction. I mean, if what he's doing is legitimate at all, if we can make sense of what it means to say that the Bedeutung of Quinean corner quotes T is T with no quotes on it. If that's intelligible, And it is, because it's an intersubstitution license, and he's telling us that we can do that, and that's coherent. Then you can introduce expressions by abstraction that are not a special kind of object, an abstract object. It doesn't follow there aren't any abstracta or abstract objects. Maybe not all the things you introduce by abstraction are like that. Maybe some of them you only can refer to by abstraction from something else. But we're sensitized, I hope, to things being able to play multiple roles, and it's a strong thing to say that there is no intersubstitution of things introduced by, say, numerical expression with something that we can understand non-abstractly on the other side. You're quantifying over sort of all the functional analyses and all the roles it can play in inference, if you say that. But it's compatible with this lesson that there are some kinds of things that are abstract in principle. That's the only way to get access to them. But abstraction is a way of getting to new stuff anyway, to be able to, it is a way of making semantically accessible new kinds of things that you couldn't refer to or make claims about before. And the very high end of ampliativity that we'll get from the purely logical techniques that Frege is introducing is going to be combining the multiple roles kind of synthetic productivity that we saw on the one side with introducing new expressions by abstraction. Frege is doing all of that and doing it so as to make sense of concepts like continuity in the mathematical sense. Euclid already made sense of the notion of density, as it turns out, there being another one between any two of these. But it was a 19th century discovery how much daylight there is between the notion of density and the notion of continuity. But Frege could make sense of that new concept, that new to the 19th century concept as well. Okay. Well, so next week we go back to reading Frege. There's new stuff there too, but there was no particular Fregean text to hang today's story on. And it seems to me to appreciate what Frege is really accomplishing, as we lay that alongside what he says about what he's doing, desperately trying to show people that there really is something new coming out of what he's doing. It isn't all in Boole there. This is the sort of intellectual context, as well as some of the historical context, that I thought would be most helpful. So, back next week to reading Frege, talking about sort of how it looks to him, what he did, how he sees it, and so on. Okay, well, thank you very much.